Hey guys, so this one is lesson 21, the Claisen condensation reactions, and I do recommend watching his video. He talked a little bit about it in class, which really helped me, but I also did some extra reading on it and some extra research. I don't know if anyone ever got the book Organic Chemistry as a Second Language, but that has helped me tremendously throughout this class. I know it's a little late now, but if you have it, make sure to read it. I only read a little bit of this part. I didn't really read the whole thing, so I don't know that much, but I will try to explain as I go along. So what we're going to do is draw ethyl propanoid. Okay, so I have like my paper of everything that I typically draw, just because I don't like Googling things. I like to just have it right in front of me because it helps me a lot. This one is an easy one to draw because it's got a simple name, but some of them have more complicated names than this. Okay, so I've got my propanoid, so propane, and this consists of my oid part, and then ethyl at the end. And I'm drawing two because it doesn't specify anything else. So we know we're going to be reacting it with itself. Roll this a little bit. Actually, I'm going to roll it this way. I'm going to move it over here and then move this one over here. So basically with the Claisen condensation products, what we're going to do, like with the aldol reactions, is we're going to be taking from this carbon, the alpha carbon with the two alpha hydrogens. I'm going to use my hydrolytic function and attach it here. The only difference is from the aldol reactions is that instead of kicking this one off, we're going to be kicking this off. And then I can go ahead and grab this hydrogen if I want to, but yeah, I'll just do it. Let me go ahead and delete all this extra stuff. So I don't think we're doing any double bonding, no. Our end product will have those two ketones, beta ketone, our little group over here. So if we added heat, we would be removing this carboxylic acid group, and that would make CO2, and then this would make an ethene. But we don't have all that extra stuff, so we just leave it like this. All my carbons look satisfied, so I'm gonna leave it and submit. Okay, this is a good example of the heat. So I have on my paper ethyl acetoacetate. So I know it can be kind of confusing when I'm drawing everything like this, but this is kind of, I usually draw everything in carbons and then I go back and change it to oxygen, but do it however you're gonna keep track of everything. So we've got 1, 2, 3, 4, 1, 2, 3, 4, and then 2. So I'm just comparing it to my drawing. So for this one, this is actually the product of the Claisen condensation. So we don't have to react this with another one of it. This is like the product. So now we move on to the base, iodomethane, hydrolysis, and heat. So I'll put my carbon, I'll put my iodine on that to ionize it. I'm going to move this, and then I'm going to deprotonate my alpha carbon. I want to use this one in between these two. So now I have a carbanion, and then I'm going to ionize this to give myself a carbocation. I'm then going to go ahead and grab it. Okay, not with this one. Let's see if okay. I'm going to roll it around a little bit so I can grab the right one. Okay, I'm going to go ahead and delete these extra little things. And the hydrolysis and heat is basically what I was explaining earlier. It's going to be kicking this off. I'm going to take one of these hydrogens just to, that's not really the exact way to do it, but I just want to take the hydrogen without drawing one on the canvas. I'm going to delete all this stuff. And this is where we end up, the end product. So I'm going to submit it and see if that is correct. Awesome. Okay, Claisen condensation product of ethyl ethanoate and excess diethyl carbonate. So I'm going to draw my ethyl ethanoate first. 2 carbons over here. I'll write 2 carbons over here. Do my double bonded oxygen, single bonded oxygen, attach it to the ethyl group. So the ethanoate is the first part. This. The ethyl goes attached to the oxygen that is single bonded to the carbon. And then excess diethyl carbonate, I believe I have that in my notes. So let me switch back to carbon, and I'm going to draw it like this. Let me add my oxygen over on both sides. So this is what it should look like. So I got 1, 2, 3, 4, 5 carbons. Okay. Let me add my hydrogens, hit arrange and fit. And let's see, so I'm going to look for my alpha carbon. I don't have an alpha carbon on this one because it is flanked by the 2 oxygen groups. So I'm going to take from this one, this alpha carbon that has 3. Move this around and then use my heterolytic function and grab down here. These 2 groups are identical, so I just remove this. I'm going to take the hydrogen, arrange it, and then start deleting this extra product that we have. So this is what we have at the end. We've got our 2 oxygen single bonded on the sides. This carbon has got our 4 bonds, and all should be good. I don't see heat, anything, so I'm going to leave it like this and see what happens. Awesome. Okay, drawing is so much easier than naming. Trust me on this. So pentanoate 1, 2, 3, 4, 5. 5. OIT. We know OIT is going to be the double bonded oxygen, single bonded oxygen. So this is going to be my 1 position. At the 3, we have oxo, which stands for a double bonded oxygen or a ketone. So 1, 2, 3. Let me go ahead and switch to carbon. So I'm going to have a methyl at the 2 position, 1, 2. And then an ethyl, it's a space right here, so that indicates it's going to be to a single bonded oxygen. So ethyl. I'm going to add my hydrogens, hit arrange, fit, and roll it around because I do need to figure out if this is an S or R configuration. I've got it right over here. And this is going to be my first because if we go out, we get carbon. If we go out again, we get 2 oxygen, 1 carbon, 1 oxygen. So 3 oxygen beats 2 oxygen and 1 carbon. So I'll just go ahead and show on my drawing just so it makes a little more sense. So I already established that all these carbons are the same. I'm going to go and switch to the arrow. And we've got 1 oxygen, 1 oxygen, 1 carbon, 1 oxygen, 1 oxygen, 1 oxygen, 3 oxygens. And of course, this is 3 hydrogens up here if we're going 1 bond out from the little circle. So that's why this is the highest priority. Okay, so now that we've established that, it's 1, 2, 3, S counterclockwise. So this should be good. Let's submit and see what happens. Getting my charger. Okay. ethyl butanoate. So 1, 2, 3, 4 OIT. We're going to have that oxygen on the sides. We're going to have ethyl because there's a little space on the single bonded oxygen. I'm going to copy that molecule because it only specifies that one. Okay, so double check. Butane, 1, 2, 3, 4. Ethyl at the end. Okay, it looks good. Fit, move. Okay, I'm going to roll this around. Okay, and this is my alpha carbon with 2 alpha hydrogens. So I'll go ahead and grab that bond and attach it to the single bonded, which will then kick off this one. I'm going to delete all this extra stuff that I do not need and hit arrange. We end up with the beta ketone, which is exactly what we want. If you have 2 carbons in between these two, then you connected it at the wrong area. And again, if it ended in hydrolysis and heat, we would then go ahead and remove this whole group. But it doesn't, so we can leave it like this. Let me roll it around. Yeah, that looks good. I don't see any carbons that are lacking. Yeah. Ethyl propanoid. Propane. It's going to have an ethyl. Double bonded. Oops, wrong one. You want to attach the double bonded at the end. Unless it specifies. Okay, so I have my propane, I've got my OIT part of that propane, and my ethyl on both of them. So I'm going to roll this around and move it over here. Okay, using my hydrolytic function, I'm going to grab this and attach it to this carbon, and I'm going to kick off this. I'm going to delete all my excess, hit arrange, and then we know that we have hydrolysis and heat, so this is going to make CO2 and ethene. So I'm going to go ahead and use my hydrolytic function to, let's see how I'm going to do it. I'm going to grab one of these hydrogens because I don't want to put one on the canvas. Do a single bond. You don't have to do all this extra stuff because we're essentially just going to be deleting it, but I like to do it just to kind of show what's going on. So this would be the actual products at the end, all 3 of these. Maybe the other one we had 2, but just so I can show you guys that everything worked out. And this is what we have, the product that we're actually going to be submitting. So 1, 2, 3, 4, 1, 2, 3, 4. Just lastly, of course, checking my carbons. There's some hard ones on here that I haven't got yet, so hopefully I'll get them. Naming, I hate naming ones. Okay, this one doesn't look too bad, but 1, 2, 3, 4. Butane. Okay, butanoate, because, okay, 1, 2, 3, 4, so we've already got this, all this part, as you can see the outline of my cursor. Butanoate, I have oxo at the 1, 2, 3 position, so I'll do 3 oxo butanoate. I've got a methyl at the 1, 2 position, so 2 methyl dash 3 oxobutanoate, and then I have an ethyl, so I'm going to do an ethyl space to indicate that it is on the single bonded oxygen. And lastly, please do not forget to check any configurations. So I think, yes, it looks like I have a center here. So I've got my highest priority on this side. If we do the counting again, we're going to get 3 oxygens once we pass this carbon, and we're only going to get 2 oxygens and 1 carbon. So first priority, second, third, counterclockwise. So in front of that ethyl, I'm going to put S. And then the last step is going to be me looking at my notes and seeing if it has something similar, just to see if my naming is correct. And what I also like doing is writing all this down and then Googling it and seeing what comes up, because it kind of gives you an indicator of if you're going in the right direction. So I actually have this exact molecule. It's like this, so I'm going to move it like this so I can compare it better to my notes. So I've got my oxygen, my ethyl, my double bonded, my this over here with my hydrogen sticking out in my notes, and I have an ethyl over here. Oh, I have oxopentanoate. So this looks right for a butanoate. So I'm going to submit and hope that everything is good. The naming ones are probably the hardest, but they're also kind of the easiest because even if you get it wrong, you still get the answer at the end, and you can next time if you take it, you have the answer basically. 1, 2, 3, 4, 5, 6. Hexanoate. I'm going to jump up to the beginning and add my oxo. So at the 1, 2, 3 position, I have oxo. At the 1, 2 position, I have this. And I think I actually have this one I couldn't get, and I finally got it. Let's see, 1, 2, 3, 4, 5, 6. Awesome. So like I said, if you keep doing it, you eventually get, or with these, you're going to get the answer. So it does help a lot, because even with the drawing ones, if you get this, you get it wrong, and next time you have a drawing one, you'll have it in your notes already. So to isopropyl, I think last time I put methyl ethyl and it was wrong. I've got a methyl the 5, right? 1, 2, 3, 4, 5. Yes. Oxohexanoate. I'm going to jump to the beginning and specify that I have an ethyl at that single bonded oxygen. I'm going to jump to the beginning again and look for a chirocenter. It's right over here. Let me zoom in right here. Got my highest priority, second, third, counterclockwise, so it's S. Okay, I'm going to double check my notes because I have not been able to complete this homework. Isopropyl, 5-methyl, 3-oxohexanoate. I just feel like I'm going to get one letter wrong. Okay, I'm going to submit. I don't want to, but I have to submit at some point, and I don't see anything that I can change. Okay, here goes nothing. Of course, what did I miss? Oh my goodness, I literally put this the first time, and it said it was incorrect, and it gave me this answer, so that's why I put this. So what I'm guessing is that there's 2 questions like this. You might get it wrong if you put this answer even though it's correct on the other question. Wow, I even have the video. I'm gonna try to insert it here where it gave me the correct answer was exactly this one. If it doesn't take me too much time, I might add it. If it's not, then you can ask me to show you, and I'll show you. It's ridiculous. So at this point, I'm not sure which answer to put. It's kind of 50-50. Yeah, I'm not sure which answer to put. I guess when you see this drawing, a naming, just pick one and then hope for the best. Because I did put this the first time and it was wrong. So yeah, all I can think is that there's two questions like this and they come out at the end, and either we're all gonna get a 90 or yeah, I'll leave it at that. Ethyl acetoacetate, acetoacetate, so I'm gonna draw that. Hold on, I gotta... Sorry, I'm working, so I gotta go back and see what they need. This is acetoacetate. It's already the Claisen condensation product. I'm gonna draw my bromopentane down here with my bromine at the 3 position. So all we're gonna do for this one is, okay, hold on. Okay, sorry guys, I am working. I'm sorry, you can just skip that part. Okay. So I'm going to ionize this carbon that I have on the bromopentane. Using my hydrolytic function, I'm going to remove that bond, and then I'm going to deprotonate this carbon and create a carbanion, and then I can go ahead and grab that carbocation. Delete all this bromine, hydrogen, and this is what we will have at the end. I know it's a little messy. Let's see if I can move some things around so it'll be easier for you guys to see. So that's a little easier. Okay. That looks good. And I'm gonna leave it like that. Okay, ethyl ethanoate, so 2, just like that. Base hydrolysis, so we're actually gonna do 2 of them because it's not the condensation product yet. So I'm gonna react it with itself. add my hydrogens, fit, move some things around. I'm gonna roll this. Okay, so I'm gonna use my hydrolytic function and grab from this alpha carbon, grab and attach it to this one, and then I'm going to kick off this. I'm gonna delete all this extra stuff and fit it so I can delete these hidden hydrogens. And then lastly, we have hydrolysis and heat. So I just go ahead and kick this off. Actually, I want to use that to grab a hydrogen, and then I'll just delete everything else. So we're kicking off the group, the carboxylic acid group that has the double bonded oxygen and single bonded oxygen. And this is what we end up with. I know it's a little weird when we have like a bigger molecule and we only end up with like a little one, but this is basically it. I believe that was the last question. Okay, so be careful with the naming ones. Sometimes you can look them up and it's wrong. I would suggest just writing them down. That question, I don't know which I'm going to put next. I guess I'll try the methyl ethyl again, even though when I did it, it was wrong. But yeah, good luck, and hopefully we can get 100 on this. Bye, guys.